Good morning, everyone, and I'm thankful to Dr. Vibhuti P. Sinha for making me a part of this IC. I'm going to talk about corneal topography, how to conquer corneal topography. I have no financial interest in any of the product mentioned here. Corneal topography is the science of describing or representing the surface of cornea. There are two types basically, surface topography, which uses the Placido-based system, and elevation-based topography, which uses Scheimpflug camera to give the three-dimensional image, that is, it's a tomography rather than a topography. In Placido-based system, a series of concentric illuminated rings are reflected over cornea, and the size and distortion of ring pattern is analyzed to give the final picture of topography. But it has got many limitations. As we are not talking about the posterior corneal surface, we cannot talk about the pachymetry. And plus, the images from the peripheral portion of the cornea, they are mostly not so good. So they are kind of extrapolated data. So it doesn't give a very accurate results in peripheral part of cornea. And that is the reason why we shifted to elevation-based topography, which gives or considers all the three coordinates X, Y, and Z. But the problem here was of limited accuracy, and that is how the concept of integrated topographer came into picture, which uses the topography of, or the curvature data of Placido topographer and the Scheimpflug data of elevation-based topographer. And the gold standard of corneal topography right now is Pentacam, which is a integrated device using both the datas. It considers nearly 25,000 true elevation points to give the correct topographic picture. In a typical corneal topography map, we have two portions, one on the left side, where we can see certain digits, and on the right side, we can see certain color-coded map. We'll start with the left side. It has got 5 portions from top to bottom: patient information about the front surface of cornea, back surface of cornea, pachymetry, and other parameter. In patient information, what is the name, when this examination was done, what is the date of birth and all. For the front and back surface of cornea, we start with the quality of scan, whether we can trust this scan or not. If it is okay, then we should go ahead. Then Q value for the anterior surface, it should be prolate. It should be negative, less than minus 0.5. This is the horizontal radius of curvature and the corresponding K1, vertical radius of curvature and K2, mean radius of curvature, K mean, what is the amount of astigmatism at what axis, what is the minimum radius of curvature, and what is the peripheral radius of curvature. And the similar value will be given for the back surface of cornea also. The only difference would be the power will be negative. Then comes the pachymetry. We consider pachymetry at 3 important points, one at the pupillary center, one at the pachy-apex, that is corneal apex, and then the thinnest location. Then we take pachy-apex or the corneal apex as the point 0 and try to see how far is the pupillary center and the thinnest location is. Then the other parameters which we consider is the corneal volume, keratometric power deviation, chamber volume, what is the angle of anterior chamber, how much is the AC depth, then pupillary diameter, what should be the correction of intraocular pressure, and the lens thickness. The right side of the map uses the Louisiana State University color-coded pattern, according to which the cool colors like violet and blue, they represent low power or the flatter curvature. The green and yellow, they show the normal cornea, and the warm or hot colors like red and orange, they represent steep curvature or higher power. In a typical display, we get 4 maps. The first one is the sagittal map or axial map. The second is the anterior elevation. The third is the posterior elevation, and then comes the corneal thickness map or the pachymetric map. The anterior axial or sagittal map is mainly for examination purpose, just to screen out. If anything is grossly abnormal, it will be apparent here. We calculate the dioptric power at every point, and then we just put it over there. But if we want to read one point in detail, then we need to trust the tangential map, because it considers every point as an individual circle. So if anything goes wrong, it will come very highlighted here. Corneal thickness map, as I said, it considers 3 locations: the pupillary center, the pachy-apex, and the thinnest location. Then we take pachy-apex as point 0 and see how far is the pupillary center and the thinnest location by X and Y coordinates. The corneal thickness spatial profile, this is to know how the corneal thickness is changing from center to the periphery. What we do, we take the thinnest portion of the cornea, or the thinnest point of the cornea as the center, and then we draw 22 concentric circles around it. On every circle, we measure the pachymetry, and then we draw it from center to periphery, like this, 0 to 2 millimeter, 2 to 4, and so on till 10 millimeter. Ideally, the test cornea should fall between the 95% interval, that is these two black interrupted lines. So if we have a cornea like this, where it is although falling within this interrupted line, but it is not following the normal curvature. So definitely we can't call it normal. This was actually a case of post-cataract corneal edema. As we can see, the central thickness is as thick as, central portion is as thick as the peripheral portion. Elevation map. This is the most important map for any integral topographer. What we do here, the machine gives a reference body. This can be a sphere, ellipsoid, toric, or anything. We can choose that. Then the given cornea will be compared with this cornea. For example, if we have a test cornea in yellow color, this reference surface is here. So a portion of cornea will be above this reference surface. This is elevation. The point of correspondence will be point 0, and the portion of test cornea which is below this reference surface is called depression or negative points. So based on this, we have this Bellin-Ambrosio algorithm, which is very widely used for refractive screening. According to which, if we take the central 8 to 9 millimeter zone of cornea, if the difference between the best fit sphere and the actual corneal contour is more than 15 micron, this is keratoconus. Between 12 to 15, this is suspicious, and less than 12, this is normal. These are some of the normative value which we use for screening purpose, like K reading should be ideally less than 48 diopter for refractive surgery. The corneal astigmatism should be less than 6 diopter. The thinnest location should have a Pachy of at least 470 micron, and within the 4 millimeter circle, the anterior elevation should be less than 14, 15, and the posterior should be less than 20. These are some of the common points, and using this, now we'll try to interpret a few. If we have a cornea like this, as we can see, nowhere the dioptric power is more than 48, we will just consider the 3 to 4 millimeter circle. On the machine, we can change this actually. And then the anterior elevation is nowhere more than 15, posterior nowhere more than 20, and the Pachy seems to be normal. So this was a case of normal corneal topography. Here we can see we have a cornea which is like 45.9 here, 44.4 here. So this axis, the vertical axis, is steeper than the horizontal one. Here the anterior elevation seems to be normal. The posterior elevation in the central circle seems to be normal. These points, they actually show that the meridian is going down. That means it is vertical. And the pachymetry here is again normal. So here we have a cornea which is like vertical is steeper than the horizontal. So this is with the rule astigmatism. Now here what we have? Here we have a cornea where the dioptric power seems to be normal. The anterior elevation is normal, but look at this point. This is plus 20, which is definitely suspicious. In the central area, if you have a plus 20, now consider the pachymetry at the very same point. You can change the cursor and see the Pachy at that very point. It seems to be normal. So this could be a case of early keratoconus, which has started from the posterior surface. So these are the cases where we shouldn't just jump and go ahead do the refractive surgery. We should be very cautious about this. This is a clear-cut case of keratoconus. As we can see, the dioptric power is very high. The anterior elevation, posterior elevation going wild, and the pachymetry is very less. So this is a clear-cut case of keratoconus. So this is how we try to interpret the corneal topographic data. I think this concludes. Thank you.